I'm Mingrui Zhang from the University of Washington, and today I'm going to tell you about PhraseFlow, which is a phrase-level input system, and in this project, we empirically investigated various designs and the user's behaviors to make the phrase-level input more practical. This work was conducted by me and Shumin Zhai from Google. So I think most of us have encountered these awkward moments where autocorrection has corrected the text into wrong words. And part of the reason is the current autocorrection operates on the word level. Word level means each time you press the spacebar, the word before the space get corrected and fixed. In this example, the user wants to type "I live in Seattle," but made a mistake. And we humans can spot the error easily based on the later text, but the word level autocorrection cannot. A natural idea is, can we make the keyboard not only consider the previous text when correcting a word, but also the text after it? In this work, we made a phrase-level keyboard, PhraseFlow. It delays the correction until it sees useful information. In this example, until the keyboard says "in Seattle," it will then correct "love" into "live," which makes more sense. Let's have a look at these examples. For phrase-level input, it can correct based on the later context. So in the first example, it successfully corrected the typing into Los Angeles. It is also able to correct space-related error. In the second example, the letter N is mistyped with the space bar. And in the third one, an extra space is pressed before the character G. Because the word level input considers the space key as a hard commit, it is not able to correct those space-related errors. And here is a demonstration of the project.
We systematically explored different interaction aspects of PhraseFlow, including correction effects, text markers, commit methods, and more. Specifically, we designed the buffer commit method, which only commits the first word of the text after hitting a space, instead of committing the whole text at once. Phrase-level input can utilize the subsequently input sequences, including the space key, to correct the previous error. By utilizing the future context, it reaches better correction performance than the current word-level corrections.
And I want to briefly talk about how I implement the phrase-level correction. The keyboard is using a state machine called Finite State Transducer, FST, for autocorrection. And FST has two elements, the state, represented as circles here, and the transitions. For example, when you are typing a word, if the FST will transit from the state 1 to 2 when you type I, and to 3 when you type F. And when you type the space key, it will commit the autocorrection if there is any, and then go back to the first state. So what I did is that I disabled this transition so that the keyboard could continue working on the correction even when the space is pressed. To make phrase-level input practical, we investigated several visual designs, including the correction effect, the indicator of the active text, and the candidate display style. We also investigated the committing style, namely how and when to commit the autocorrection. The left was a commit all at once style. The keyboard will commit all the autocorrection for every 3 spaces pressed at once. And we found that this design tended to increase the cognitive load of our participants as they had to pay attention to more than one word each time the correction happened. We then designed this buffer style commit on the right, where for each key press, it will only commit the first word and keep the rest still in the active text. And we found this design successfully reduced the distraction during our studies. We conducted 7 user studies, including 2 in-lab evaluations and a few deployments. Together, we found that the phrase-level input reduced the autocorrection error by 16% compared to the current Gboard. And our participants reached 19% less word error rate in the in-lab evaluations. Our field deployment showed that over 78% of the users prefer the phrase-level input and would like to use it in their future keyboards. To know more about the design details and their evaluations, please refer to our paper. Thanks for listening.